You probably know GeoGuessr, the game which gives you a random studio location and lets you guess where it is. In this video I take you on my journey to create an AI that plays GeoGuessr completely on its own using machine learning and the browser plugin. Let's first have a look at the game itself. You spawn at a random location. Sometimes you are lucky and you get some street signs. So in this case I'm pretty sure this is somewhere Eastern Europe, maybe in Ukraine. And you do the guess and then you get some points based on the distance. And each game consists of 5 rounds, so this is another one, I guess this is in the US. And then after all the 5 rounds are completed, you get this overview which shows you your total score and all the locations that you guessed. So that was me playing the game, and in the intro you actually saw the AI playing it. But let's start at the beginning. So what do we need to make this work? So first of all, we have to take a screenshot from the game, from the actual street view location. Then we need a model that actually predicts the location, and finally we have to make a guess. So the overall idea is not that difficult, but there are some challenges on the way. First of all, how do we take the screenshot? So we can either record the whole screen and then process the image, or we can take a screenshot within the browser. If we take a screenshot of the whole screen or record the whole screen, then it's fairly easy because we could probably do that in Python. If we want to take a screenshot within the browser, we need to write a browser plugin, which is something that I have never done before. However, the advantage of a browser plugin is that it gives us more options to interact with the game, which is probably helpful later on when we want the AI to actually play the game on its own. So what do you do when you don't know how something works? Well, Google is your best friend, so I started by following the Getting Started guide by Google itself. And it turns out it's actually not that difficult to write a browser extension. You just have to create a manifest with some basic descriptions. Then you define which permissions the extension needs, so in this case, for example, access to the screen. You create the user interface using HTML and CSS, which is great because that's something I have actual experience with. And then eventually you implement the logic, so in this case to look around on Street View and take screenshots and send it to the backend. So this is how the browser plugin actually looks like. I have this icon up here, and then I can choose between the classic and the duel mode. So classic mode is basically single player and duel is to play against one other player. If I click on classic, it automatically loads the game and it clicks on start game. So that's not me clicking, but the browser extension. Then it gets the street view location, it interacts with the compass on the left to look around, and it takes 5 screenshots in total. Afterwards, the pictures are sent to the server where they are merged into one big panorama picture. As you can see, the picture is not perfect, some elements are twice on the image, but that's okay because it still contains all the relevant information. Another important thing to notice is that the resolution is downscaled to a height of 512 pixels to reduce the computational requirements. This is always a trade-off because a higher resolution gives us more information to work with, but also requires more hardware, more memory, and longer learning times. Now that we have the images on the server, we can continue with the most interesting part, and that's the implementation of the actual AI model. As we deal with rather big images, it is useful to apply deep learning. Especially convolutional neural networks are very useful for image classification and similar tasks, because the convolutional layers within those networks help to preserve local information. A convolutional neural network takes the input, in this case the panorama image, and tries to identify relevant patterns. Afterwards, it reduces the input size and looks for patterns on these patterns. This process is repeated several times until the last convolutional layer. In other words, the network starts on a pixel basis and looks for patterns until at some point it recognizes patterns of the size of, for example, a car, a street sign, or the sun. Those patterns can also be things that a human can't really recognize, but I think you get the idea. Now all we have to do is to actually implement this model in Python, and then we can continue with the training. Without the training, the parameters on our network are basically random numbers, not able to predict anything. Before we can train the model, we have to collect actual training data, and the training data has to consist of the panorama images and the actual location where the image is taken, and that helps the model to learn. In this case, I repeated the process of collecting data and then learning the model on the new data several times until it reached a sufficient level of accuracy. What you can see here is the data collection, so the browser plugin takes 5 screenshots, sends them to the server where they are merged and saved together with the location. I will fast forward this because the process takes a lot of time, as the plugin is only able to collect one picture every 10 seconds or so. The training itself also takes a lot of time, in this case 25 minutes to train once on all the images. At the bottom of the screen you can see the loss, which is what we try to minimize. The lower the loss, the higher usually the accuracy of our guesses. However, the loss shown here is calculated on the training data, and machine learning models can overfit to the training data. This basically means that the accuracy on our training data is high, but it could be that the real-world performance is much lower. Therefore, we split the data into a test and a training set, and calculate the loss on the test data once we processed all the training images. So this is basically the idea of the training process, and we repeat the training until the loss doesn't improve anymore. One iteration over the whole training data is called an epoch, and as you can see here, we run quite a few epochs, leading to improvement in the test loss, here referred to as validation loss. Let's look at the performance now in the way that the game counts it. So based on the distance between the guess and the actual location, you can get up to 5000 points per round. In order to get an idea of how many points the AI actually gets in the game, I calculated the points the same way that the game actually does it. This is a histogram for an early version of the AI showing how many points it would get on the test set. As you can see, most of the guesses would give something around 0 points. Let me play an animation to show how the AI made progress over time. There are some drops in the performance when I started to use data augmentation techniques, but overall you can see that the performance increased. These are the results for the current version of the AI. There are still some images that the AI guesses really badly, but most guesses get more than 2,500 points. Now that we have a model that is actually capable of predicting the location of an image, let's try it out. We start with the input image that we can create through the browser extension. Feel free to guess along to compare yourself with the AI. To let the AI make a guess, I moved the image into the backend folder. This script loads the image and runs it through the model that we trained earlier. The script outputs the coordinates in the terminal, which I can for example use in Google Maps or Google Earth. That way we can compare the guess with the actual location of the image. As you can see, the AI guessed some location around Birmingham in the UK. I will add the actual coordinates so that we can see how far this is off. So apparently the picture was taken in northern France, which is roughly 900 kilometers away from what the AI guessed. Let's have another look at the plan. So far we are able to take the screenshot, send it to the server and make a prediction. But before we can play the game with the AI, we have to do one final thing, and that is to actually make the guess within the game. Let's see how that works in the game. On the right side you can see all the network traffic that the game produces. Once we make a guess, the game makes a lot of requests to the GeoGuessr server. Most of these requests just load images like these tiles for the map. We are only interested in one network request, and that is this one. It posts the coordinates of our guess to the server, which is all we need for the AI to make a guess. I implemented the logic to submit the guess in the server, which basically looks like this. A final look at the plan shows us that we went through the most important parts of this AI system. We create a panorama picture out of screenshots from the browser, then we send it to the backend, where we make a prediction and finally submit the guess to the GeoGuessr server. There were a few more things to do, but these are the most important ones. I took a similar approach to also implement a duel mode, which allows us to play with one person against the AI. Okay, so the AI plays as the guy with the globe and I'm the iPad. Let's play no moving, no zoom, because that's the way the AI plays as well. And then we start the game, we set the AI in duel mode, and then we start guessing. Okay, first round. I think this might be something like... I was thinking US, but... yeah, maybe somewhere in the US, but in the south. Maybe it's even Florida. And it was not Florida, and the AI was significantly closer than me. And the second round. Yeah, the AI guessed already, as always. I will go with something Spain. And this was Greece. And I already lost. Okay, but let's do another round, because this one was pretty difficult, because the AI made so much damage so early on. So play again. Play again. Okay, maybe this is Europe. They have, this guy has a strange number plate. Maybe it's one of the Nordic countries. Let's go with something like Norway. And I was pretty close. So this time a bad start for the AI. Let's see, second round. Yeah, this looks very open. Could still be Europe, but I think I will go with something like Argentina. Oh, it was Europe. And the AI got pretty close. So there go our points. Or my points. I guess half of you guys probably knew. Oh, I don't know. I'm better at guessing when it's in cities where you can see a bit more stuff. Well, I will just go Chile. Okay, so this time that was better. The AI got closer and also guessed the country correct, but we are not out of the game yet. Round 4. There's a fuel station. Oh, I don't want to do this one wrong. I will go again South America, and I will go Argentina again. And it was wrong, but I mean, this is mostly me just being very bad. I had a chat with Rainbolt, who is actually one of the world's best players at this game. And we decided to do a duel with him against the AI. Let's fast forward the recording to get an idea on how the AI performs against him. As you can see here, he is significantly better than me and also better than the AI. There were only a few locations where the AI actually guessed better than him. Currently, one limitation of the AI is that it only guesses an area and not a specific location. And if you play against someone like Rainbolt, it's often not enough to just guess the area right. I'm also planning to improve the performance by training it on more data. If you want to see this duel from Rainbolt's perspective, check out the link in the description. Besides that, let me know if you want to see more content on this AI or if you have other ideas for interesting projects.